Hello, my name is Bob, and once again I'd like to welcome you to another episode on the White Dog Garage YouTube channel. This is part 2 of a 3-part series in which I'm going to show you how I built this portable 12-volt auxiliary battery system, or battery box, for recreational vehicle use or camping use, and I'd love you to follow along. This part is going to cover the actual wiring up of the box and how it all goes together, and I hope you enjoy. I started the wiring with the positive output side. I gathered together a length of high current cable, a length of 25 amp wire, a maxi blade fuse holder and a standard blade fuse holder. These are all for the positive circuit, so the color code is red. I then stripped the insulation from one end of the high current cable, the maxi blade fuse holder and the standard blade fuse holder. The thicker cables are too big for my wire stripper pliers, so I have to use blades to cut and then strip away the insulation. I then joined these 3 ends together, initially twisting the wires around each other to form the joint and then soldering the joint. For wiring of this size, I use an 80 amp soldering iron as a lot of heat input is required. A butane soldering iron works just as well, but an electronic soldering iron just won't generate enough heat for the amount of wire being used. Once the joint had cooled, I wrapped it in insulation tape, red again. You will see me alternate between insulation tape and heat shrink wrap on these types of joints. I prefer heat shrink, but in some areas tape does a better job of sealing the joint. I then stripped the other end of the standard blade fuse holder and the ends of 2 lengths of 25 amp wire before twisting them together, soldering and again wrapping the joint in insulation tape. I then check the layout of this wiring harness in the lid space to determine how long I'll need the wires to be. Having determined the position of the harness in the lid and the length of the wires, I then strip the ends of the two 25 amp wires. I first slid heat shrink wrap over the ends of the 25 amp wires and then fitted blade sockets to the stripped ends. I then used needle nose pliers to crimp the blade sockets to the wire ends. The blade sockets have two crimp areas. The one close at the socket end is crimped on the bare wire and the second is crimped on the insulated wire. With both blade socket ends crimped in place, I then soldered the bare wire connection. You can just crimp your connections and leave it at that, but sometimes crimp connections can come apart, so personally I prefer to both crimp and solder because I value reliability. But I have to admit it is a belt and braces approach to the job. So, you don't want to get caught with your pants falling down now. You need to take a belt and braces approach. Trust me on that one. I then drilled one more hole in the top of the lid. This hole will take an 8mm bolt, which will act as a central negative, earth or ground point for the wiring. Off camera, I've already made up an earth cable, colour-coded black of course, which I then fitted. This cable will provide the ground connections for the voltmeter and the accessory socket. Off camera, I had also made up a connecting wire with blade socket ends to run between the switch output and the voltmeter, which I then also fitted. With those wires in place, I then fitted the output wiring harness blade sockets. I want to spend a minute talking about high current plugs or Anderson plugs. You hear me refer to them probably regularly as Anderson plugs because in the trade that's what they're commonly called, but the correct name is high current plugs. These plugs are used as a means of connecting particularly battery current together, or in this case high current devices or connections. They take 50 amps and you can get slightly bigger ones which will take a higher current. There's no male or female. There is a positive and negative, but you turn over and they just connect like that. So it's the same plug, it's just turned over to connect, and obviously positive to positive, and there you go. Now, when you feed the cable, you've crimped on your connector, and I'm hoping you can see there is a slight hook. A slight hook there. Within the connector, there are two metal flaps, and that hook goes over, it's a spring clip actually, and the hook goes over the end of the flap. So, with the hook end there, it's on the bottom side, and you line it up and you push in, it will go past the clip, and once it gets to the end of the clip, the hook grabs the clip and it won't pull out. If you want to get it undone, the way to do it is to get a screwdriver in and pushing the lead forward with a bit of juggling. So you basically, to get it undone, you're putting the screwdriver in, you're putting your screwdriver in, you're pushing this spring clip down just on the side, and then you're merely pulling back on the lead, and that will release it. I then fitted a high current or Anderson connector to the high current output wire of the harness. At the same time, I also fitted the earth cable for this connector. The high current or Anderson plug is secured in place by two screws, and after determining where it will go, I then drilled holes in the lid to take those screws and fix the plug in place. I then stripped the other end of the high current earth wire and then crimped and soldered on a lug to enable it to be mounted to the ground point bolt. You may notice I don't always insulate the earth connections with tape or heat shrink. In my opinion, it's not necessary if they are not in close proximity to a positive connection. At this stage the output side wiring was all but complete, with only the fitting of the lug to connect the battery remaining to be done. Rather than take you through endless connections, it's probably useful at this stage to show you the completed wiring and to just trace the various components. So we started off making the positive lead, taking power to the output. So we'll start here at the battery. This is the positive terminal and red leads for a red terminal. We've made a split here and joined it. We've taken off our high current line. We have a connected in line, a 50 amp maxi fuse, blade fuse, and that goes out here to this Anderson connector. Also from the split is this line. This runs to a 20 amp fuse. This runs to this 20 amp fuse. It's a normal blade fuse. Splits again after this fuse. One line going to the switch and one line going to the 20 amp accessory plug. We have put in this bolt as a common earth. Rather than have many connections, I prefer to have something like this where you have a stud where all the earths are connected. And what this also means is that if you're tracing a fault, you can easily disconnect a component. So from the earth, we have two earth wires going to the componentry. One goes to the 20 amp accessory plug and the other one goes to the voltmeter. The voltmeter we don't want to be on all the time, so it is switched. So the power to the voltmeter is switched here at this switch, can be on or off, and that will turn on the voltmeter, making a circuit. Okay, we have our second power line here, and this one comes from the output of the DC charger. There's also an earth here, a common earth again, and the earth is feeding to the DC charger. We have other earth lines that go, one to the battery here, to the negative on the battery. Other earths go to the Anderson plugs for the battery input from this vehicle, or to the solar input from a solar panel. These two wires here, which are for an external indicator and the ignition in the case of a smart alternator, they have merely been terminated and shielded so that they will not short out. This roll of black line here is merely a temperature sensing module which is taped to the top of the battery, and it tells the DC charger whether the battery is getting too hot, that is, the charger is providing too much current to the battery, and that enables the charger to ease up a little bit. So returning to the top here, we have the DC charger. Here is the output, a high current output supply, a somewhat lower current output supply, which is for an accessory plug, and the voltmeter that tells us what sort of current, what sort of voltage, sorry, the battery is. Looking at the back, we have the solar input. There's no solar input at the moment. And we also have the battery input, which we don't have at the moment. So depending on whether you want to run solar power in or battery from the vehicle in, you choose which connector you go through. You can run both. You've got a solar panel on the top of the vehicle, you can connect it in here, and you can still run the vehicle voltage in here. And the DC-DC charger, or this particular one, will deal with that. So that brings us to the end of part 2, and we're all wired up and we're ready to roll. I hope you enjoyed the video, and if you did, I'd love a thumbs up, and please share it widely. If you are not already subscribed and you want to catch the next part in particular, but you want to see the channel anyhow, then please subscribe. It's easy. Hit the bar down below, the subscribe bar. While you're there, ding the bell so that you're reminded next time a new video comes out. And if you're only here at part 2, it'll remind you when part 3 comes out. However, if you've come in late, and that's all right, then there'll be links somewhere up there on the screen in which you can follow them to get parts 1 and 3. And you're more than welcome to go there. Thank you once again for watching.